Our next. Moving on. Diving into chain rules, see how it works. Told you to give you the proper. There you go. If g is differentiable at x and f is differentiable at g of x, then the composite function big F is equal to f composed of g, defined by big F of x is equaling f of g of x, is differentiable at x and f prime is given by the product. F prime of x is equal to the derivative of the outside with the inside left alone multiplied by the derivative of the inside. In Leibniz notation, it could be written a little bit differently. This is stuff that, oh man, I wish I would have paid more attention to. It's a chain saying if you want to take a derivative on y with respect to x, you might have to go through some other variable first, like u. U might be a function of x. Give it time, give it time. We'll move forward. You need to get a little bit more accustomed with it. You're going to have to play around with some games in your homework. Give yourself a break. It comes naturally, just with practice and time. Now here's a nice little classic, simple, once you get it sort of problem. Now what I'd like to do is I'd like to just make sure that we understand what's the inside and what's the outside function. And I'm going to use a dummy variable when I write stuff, because the outside function is kind of hard for me to write. So I'm going to use z as a dummy variable. So we're going to say, let's start with the inside. The inside is no big deal, or what we're calling like that g of x. We could say that it is 13x cubed minus x squared plus 1. And let me change this f. Let me change it into h, just so we're not confused on it. Or actually, let's make it simple. Let's just call it y. And then so that's the inside, right? That's just the shit that's sitting inside that parenthesis. Now the outside function, I got to use a dummy variable because it's just something to the fourth, right? It's whatever that parenthesis is to the fourth. So maybe a dummy variable, I'm going to use z. Maybe we can say it's z to the fourth. Now our formula says, now I'm not gonna put it in. I'm just gonna say that the derivative, and I can keep speaking it over and over. Then we're gonna take a derivative on the outside and leave the inside alone. We're gonna take a derivative on the outside, and we're just going to leave the interior alone. So what would happen there? That would be derivative on the outside. The 4 would fall to the front. We'd be left with a q. But what that z is this. It's just that. That's what z is. I just don't want to write it. I don't want to get too confused on it. That's just your z. So you're going to leave that shit all back behind. Now we multiply here by the derivative of the inside, right? And there it is. So our g prime of x, we're going to get 39x squared minus 2x. And I'm not going to simplify anything at the beginning here, okay? I'm just going to leave them for now because I want us to catch the pattern. And there's our solution. So write it up. Y is equal to f of g of x. Its derivative, let's see if we can't check it, is take a derivative on the outside, right? We would just think that 4 falls to the front, we'd write a 3. And then leave the inside alone. And then leave the inside alone. Once you've left the inside alone, you're going to multiply by the derivative of the inside. So for us, in our problem, our 4 fell to the front, right? Became the 4 there, and we subtracted 1. We leave the center alone, and then we multiply by whatever the derivative of the center is. And that is how we process the chain rule. I'm going to give you some of the worst looking chain rules you could ever freaking imagine. It's how we just kind of pay our dues and we get good with this. I'll jump into the next. Here's number 2. Immediately I look at this and I don't like it. That I can deal with. That's okay. So our inside, or our g, is 3 minus x. Our g prime is negative 1. Let's put equals there. I'm getting weird. All right, slope of that line. And then our outside function, our f, is something to the 1/2 power. I don't even like writing a z or anything, because I'm not going to write shit as I actually go through and do these problems. F prime is that 1/2 is going to fall to the front. And then we're just going to subtract 1 from it. We're going to have something like this. So there's your f prime, the outside. But this is actually like how to look at it. Here we go. I'm going to start solving this y prime. Now I have all the information on the right, and you can maybe start to follow it. But I look at this 1/2 is just going to fall to the front, just like a power rule would. I'm going to get 1/2, and I just leave the stuff inside alone, and now I need to subtract 1 from that 1/2. That's negative 1/2. Once you're done dealing with the derivative of the outside and leaving the inside the frick alone, then, and only then, you're going to multiply by the derivative of g. You're going to multiply by the derivative of g, and it happens to be that for this one, it's just negative 1. Now I'll clean this up. I'll write it like this. And there it is. We just found the derivative of our function. Just leave g right inside of f prime, and then multiply by g prime. Let's keep going. What's the inside and what's the outside function? This is kind of where it gets a little weird. So inside, right? That's the 3x. So our g of x is equal to our 3x. Our g prime, that's equal to 3. All right, so our f of x, well, there's no x there. We got e to the something up here. It's e to the something. And the derivative of e to the something? What's the derivative of e to the something? It's e to the something. So here it is. We're going to take this thing. All right, so the derivative. The derivative is, take a derivative on the outside function. Oh, you mean just leave that shit alone? Just leave it alone? Because what's the derivative of e to the x? What's the derivative of, if I was to make this e to the z? It'd be e to the frickin' z. It wouldn't make any dang difference. And z is just this. This is just what your z is. It's just 3x, so we leave that shit inside there. And now we just need to multiply by the derivative of g. Dude, it's just 3. Let's clean it, and we say it's 3 e to the 3x. Now I'm just going to pop off about like 7 or 8 of these things real quick. Let's just go. Y equals e to the sine of x. All right. Its derivative is, leave it the frick alone. Now, what's the derivative of sine? Cosine. Multiply. Done. Let's go to the next. Y is equal to e to the x squared plus 2x minus 3. What's its derivative? It's e to the x squared plus 2x minus 3. Now, just take a derivative of the numerator. That's going to be what? 2x plus 2. The numerator. Shit. The exponent, not the numerator. And there's our answer. Are you starting to catch what's going on here? Starting to get it? All right. So now this one. Y is equal to e to the 7. So the derivative of that one's going to be 0. All right. Sorry. It's just a constant. Now, y is equal to e to the sine of x times cosine of x. Well, y prime is just going to be, well, you could just write it down. But now we have to multiply by the derivative of our sine of x cosine of x. Our sine of x and our cosine of x. Remember that product with an f and a g, and then you can have like an f prime and a g prime down below? So what's that? Cosine times cosine, that's cosine squared. And then sine times negative sine, that's negative sine squared. Oh, cool. Cool. Hey, that brings me to something. Do you know what that equals? If I was to ask you to completely simplify this, do you know what that would equal? Do you know that's cosine's double angle? It is. You should have that on lock. So maybe I'd clean it up like this. Cosine of 2x times e to the sine x cosine x. Just want you to see e's with chains. Huh? One more. One more. What's the derivative of e to the x? Let's do the chain rule. Y prime is equal to e to the, leave your x alone. Oh, now let's multiply by the derivative of x. What's that? 1. So it just equals e to the x. You do a chain in every single freaking problem. You just don't know you're doing a chain in every problem. Every problem has a chain in it. We just don't tell you it yet. So we ran through, we did a few of these. So the e's I just played around with. Leave it alone and multiply by the derivative. Leave it alone and multiply by the freaking derivative. Leave it alone, then multiply by the damn derivative. Chains are fun. The next one, I'm going to give you just awful, terrible, giant freaking problems. It's probably going to turn into something you're going to have to turn in for credit. I will see you in your next